let me get my pen. So I'm sorry, I'm a little bit slow because of the effect medication. Right, so this one. Right, so the question is integrate this function whose integrand values are shown in table 1. So basically, all the values for e to the power x square is given in this table. Okay, 1, 1.05, 110, and so on. So what we are going to do here, is to basically integrate this function from 1 to 1.4, and the values of e to the power of x square is given here. Is given in this table. Okay, at 0.5 interval or h 0.5. So whose integrand values are is shown in table 1 numerically. So integrate numerically with h equal to 0.1. Sorry, this is 0.05. As you can see, this is 0.05, 0.05, 0.05, but there's a typo here. It should be 0.05. The value is 0.05, but what I typed here is 0.5. So let's correct this one first. Let's make a correction there so it's become very clear. Okay, so I didn't see that one. So this is, this should be 0. This should be 0.05 interval. Sorry, 0.05 interval. Okay, so from here to here is 0.05, 0.05. Okay, so that's the correction there. Just typo. The info is correct, but the typo in the table. So use rectangular midpoint rule. Okay, so if you recall last time when we discussed about integration, we discussed about this. Okay, this is from my previous lectures, where we say we can use this this rule. This is midpoint rule. Sorry, this is a rectangular rule because the shape of the area is rectangular. Okay, so you can use either point, any point here, because it is based on the approximation of f is about a naught. Okay, approximated to f to a naught. A naught is just a constant. So this is one constant. Okay, this is also one constant. And at midpoint here, this is also one constant. So what we want to do is to find the best value that we can use to approximate the area. Okay, that's the idea behind rectangular rule. So that is why in my question paper, I say rectangular midpoint rule approximating basically a polynomial of order 0, which is just a naught. Okay, any constant value at on the curve. Okay, so that's the one. So what I did here is I think I have an Excel. Here. Show you. Before that, can you see the Excel screen here?
No, doctor.
Oh, okay. Okay. Let me correct this the setting. Okay, never mind. Before that, before I correct the setting, let's go one by one. What is meant by rectangular rule and trapezoidal rule. Trapezoidal rule is based on approximating polynomial of the first order. Okay, the rectangular rule, okay, rectangular rule is just order 0, order 0. But for trapezoidal rule, we are using a first order polynomial approximation. So in that case, you can see that what we did here was approximating this curve. For example, we have, let's say this is the curve. Let's say this is the curve, and let's do a better job here. Okay, let's say that's the curve, and these are the two limits. So instead of using a constant, okay, a constant just like the rectangular rule, what we did is using 2 points. So that 2 points is a0 plus a1 x. So there are two unknowns here, a0 and a1. So which means we need 2 points. And if you solve this, you can see that this is just your straight line, mx plus c. So this is a straight line. So we approximate the curve as a straight line, as a straight line, as a linear line, or a straight line in this case, right? So hopefully this is a much better approximation than the rectangular rule, okay? This is what we call the left sum. This is what we call the right sum. In this case, this is what we call the midpoint, the midpoint, okay? So this is how we do it. So that is why, again, that is why I mentioned this in my question paper, A1, A0 plus A1x. And the third one is the Simpson's one-third rule, where we use the quadratic or a second order approximation. So we need 3 points here because we have 3 unknowns, A0, A1, and A2. So we need 3 points because there are 3 unknowns. So we need 3 points to evaluate what is A1, A0, A1, and A2. Okay, so that is what we need. That is what we need. So this table can be used to solve all these 3 parts. Okay, and then if the analytical solution is this, which method produces the most accurate approximation? So what I need you to do here, because you need to compare the errors, the relative errors. So which one has the least errors? So the one with the least error is the best method, is the best approximation. Okay, so now, just like I mentioned to you just now, I have my Excel. Let me show you if let me show you my Excel here. Okay. Okay, so this is my Excel. This is my Excel. It's kind of small. Let me zoom. So these are the values. These are the values. I just copy paste what we have on the question paper. Okay, so the question asks for using h equal to 0.1. Using h equal to 0.1. Using h equal to using rectangular midpoint rule, approximate the function. Approximate this. Okay, so in this case now, okay, so note that I need to use from 1 to 1.1, and then from 1.1 to 1.2, 1.2 to 1.3, and 1.2 to 1.4. So in this case, My Excel is not responding. Let's wait for a few seconds. Okay, now it's back online. Okay, look at this. So what I did here is that okay. So for rectangular point, we need to use h equal to 0.1, right? So this is one interval. This is second interval, third interval, and fourth interval. So what we need to do is to find the area for this first interval. And I'm using the midpoint, which is, this is the midpoint between 1 and 1.1. And this value is known. This value is 1.05, which is 3.011. So in this case, what I need to do is 3.011 times 0.1. Okay, so this is the first area. And then the second interval is this area here. Okay, this area, which is 1.15, which is this one. Okay, this one times with 0.1, and the same thing here. Okay, the same thing here and the same thing here. So this is the idea behind midpoint, rectangular midpoint rule, rectangular midpoint. Okay, so this is what I get. This is what I get. So add up this and this and this and this, we get the area for the whole interval from 1 to 1.4. So I did that with my Excel. So this is the midpoint, which is this times 0.1. So this is the one, 1.15. The value at 1.15 times 0.1, which is this, and this, and this. So the total area is 1.772251.805. Okay, so basically, this kind of question is testing on your understanding. There's no heavy calculation involved. There's no heavy calculation involved. It's just times 0.1, which is just 1 decimal point difference, and then adding up all the intervals. So this is what the midpoint rule. And now let's look at the trapezoidal rule. Trapezoidal rule is the same, basically just this point and this point. Okay, that's one interval. This point and this point, that's the second interval. This point and this point, that's the third interval. This point and this point, this is the fourth interval. So again, in my case, the formula for trapezoid is half times A B times H. So basically, what I need to do is find the average of this and this, the average of this and this. Let me show you here. Okay, so basically 0.5 times this plus this times the interval, which is 0.1, which is 0.1. So I get this value, and the same thing, this plus this times 0.5 times this interval. So this one, okay, this one. And then for the next interval, this plus this divided by 2 times the interval, which is 0.1, which is this. Okay, and the fourth interval, the same thing, this, and what I get is 1.79. 1.79. Okay, now what happened? Can you still see my screen?
No, Doctor.
Is it okay now?
Okay, Doctor. It's the Excel.
Man, this is scary. All right, so okay, now the next thing is the Simpson 1/3 rule. Okay, 1/3 rule. So what is Simpson 1/3 rule? Simpson 1/3 rule is basically evaluating or approximating using 3 points, right? Using 3 points. So instead of only 2 points, we need to use 3 points. Yeah? And because h is 0.1, so we need to use this point, and this point. Okay, so that is considered as one segment for Newton, sorry, not Newton, Simpson 1/3 rule. And this one, and this one as the second segment. As the second segment. And look at this. Oh, sorry. Sorry. It is in my Excel. Okay, so all right. So let me copy this and let's use somewhere here. Okay, so let's say this is my Simpson 1/3 rule. So note that we need to use note that we need 3 points, right? So I mentioned just now we need to use this point, and this point because the interval is 0.1. So this is 0.1, 0.1, and 0.1. So, yes, 0.1 and 0.1. So this is the first, I think my PC is also not in good health. Apa dah jadi ni? Sorry it's not responding Okay, so I don't know how to delete this. Okay, never mind. So I need to use, let me change that color, this point, and this point. So this is 0.1, 0.1, and this contribute into one, oh, okay, now I see what's wrong. So this is one segment. This is one segment from here to here is one segment. And I have another segment from here to here. Okay. Okay, so this is another segment. This is the second segment with 3 points. So 0.1 and 0.1. And note that when we use trapezoidal rule, it is like this, right? We are connecting the 2 points using a straight line or a linear line. When we are using midpoint rule, we are connecting the 2 points using it midpoint value like here, and this is the area. But for For 1/3 rule, we are using 3 points, which means we are using quadratic approximation. So maybe it looks something like this. And if you see the, again, not responding. If you see the, oh, I don't know what is wrong here. So when I'm using 1/3 rule, Simpson 1/3 rule, so please ignore all those. Tak boleh nak delete benda ni. I try to delete this, but it won't work. It just won't work. Okay, so what I did here, I'm using this point, and this point. So the formula for Simpson 1/3 rule is in your slides, in your lecture slide or in your textbook. So this is the value here. So 1/3 times h, which is A4 to A2, which is just 0.1, times B2, this value, plus 4h, 4B4, this one, and plus this. Okay, so let me rewrite that. I don't think you need, I don't think I need to rewrite that, but, okay, so the equation is just 1/3. Okay, this is why the Simpson rule is known as 1/3 Simpson rule times h times h I need to wait. My PC is not healthy, just like me. Okay, so it's frozen. Maybe it's not allowing me to write anything. Okay, let's try again. Okay, 1h times f I minus 1 plus 4 fi plus fi plus 1. In this case, this is my fi minus 1. This is my 4. Not 4. This is my fi. This is my fi. Fi, and this is my fi plus 1. So that is why I need my 3 points here. Okay, this is what I meant by the 3 points. So this is what I did for my Excel just now. Okay, so because it's not enough for in the question, you need at least two segments of to integrate using Simpson rule. So in this case, okay, so in this case, this is my fi, this is my fi minus 1, and this is my fi plus 1. Okay, all right, so, and the area is 1/3 h fi minus 1 plus 4 fi plus fi plus 1. And again, this is for the first segment. And for the second segment, okay, for the second segment, I'm using this as my f Uh, F. Oh man. Have you heard about Murphy's Law? I hope engineering student knows what is Murphy's Law. Fi minus 1. This is Fi. This is Fi plus 1. And this is for my second segment, which is 1/3 H Fi minus 1 plus 4 Fi plus Fi plus 1. So that's what I did in my Excel. And if you look at the answer, this is my solution here. This is my solution. Okay, this is my solution. All right, so this is what I got. And it says that if the analytical solution is 1.77824, okay, what is the most accurate one? 177 to 179. So definitely this is out. This is 177 2. This is 1778. So this one is out. So you can see that Simpson 1/3 rule is the most accurate approximation. 17783, but the analytical solution is 17782. Okay, when you calculate the relative error through relative error, relative to error, you see that the 1/3 Simpson rule is much has a less error than has the least error than the other methods. Okay, and why is it has the least error here? Anybody? Anyone? Remember that what I talked about in our lecture last time? Remember this? Remember the definition of integration last time? Oh, it's not here, yeah? I don't. Remember what's the definition of integration last time? It says that integration is when limit limit h I equal to 0 to n, okay, where h approaching 0, okay, so of f of fi so note that the smaller the h, okay, the smaller the h here, we can get better result, good result. And the other one is there are two methods of improving the approximation. One is by making h smaller, and the other one is by approximating our fx, okay, using the highest possible polynomial. That's two things. So in our case here, you can see that our h is a constant value. We do not change our h. Our h is 0.1, but what we did here, we change our approximation polynomial, which is this is a0, this is a0 plus a1x, which is linear, and this one is quadratic. Okay, this is quadratic. So, and we found out that this has a much better accuracy than the other two. Okay, so this is the reason why, because we are using a higher order approximation polynomial. Okay, that's the reason why. Okay, of course, in your textbook, there's one more, I think Simpson 1/8 rule, which is using cubic, using P3x, which is A0 plus A1x plus A2x square plus A3x cube approximation. Of course, the higher the order, the tedious is the calculation lah. The tedious is the calculation. So in our case, I just showed you up to up to second order polynomial, and I think this is good enough for our approximation lah. Okay, so now let's look at the second question. Okay, data in table 2 is obtained from a standard handbook. Using the data, determine a function that represent all the data. Remember, someone told me, asked me, dia tanya saya, dia tanya, function tu untuk dua point saja ke? No, I said it's all the data here. All the data, which means all this data point here, 4 ni, will have one equation. One function or one equation that represent all this data. That represent all this data. Okay, and once you know the equation, find what is the value for 2.5. Untuk 2.5. So if h is 0.5, calculate the integration of the function using trapezoidal rule and Simpson's 1/3 rule. Okay, determine the analytical result and comment on the accuracy of both approximation in part C. So basically, these two questions are the same, except that now the function is not given. It is given only in form of data points. Okay, in form of data points. That's one thing. The other thing is it is also not giving you the analytical result. Okay, the analytical result for you to find the relative error. So basically soalan nombor 2 ni is a little bit, the level of the difficulty is a little bit up than the first question. Okay, so the first question is basically testing your understanding. What is Simpson's rule? What is trapezoidal rule? What is rectangular rule? Okay, but the second question is a little bit harder than that. Okay, because you need to find the function first. Once you know the function, then you can do the integration. Okay, so this is typical question. Soalan nombor 2 ni, this question number 2 is typical of your test question. The level is typical of your test question. All right, so how do you do this for question number 2? Anyone? Can you suggest me a method to solve this problem? Question number 2. Anyone? No one? Okay. Okay, I haven't had the chance to look at your papers because I spent my weekend basically lying in bed tak boleh nak bangun. Okay, so let's do this. Let's look at my Excel again. Okay, let me close this. Macam mana nak buang benda ni? Okay, let me export this to a new book. Alamak. Oh, tak apalah. Saya copy je. Saya buka a new one because something is wrong. I don't know what's wrong with my Excel here, or maybe I do not know how to use this Excel. Let's copy the data. This is from the textbook. Don't save. Open a new one. Oh man. Okay, let me close everything here. Ah. This is frustrating. Okay, let me open a new Excel. And let's plot the points. Let's plot the point. Okay, good. All right, so these are the data points. These are the data points. And let's plot this point here. Okay, so given this is the data point, how do we find the equation that represent all these 4 points here? Anyone? 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 How can we find the equation that represent all these 4 points here? Oh, sorry. I didn't share my Excel yet. Okay, sorry. Let me reshare this. Okay, so I plotted this data. I plotted the data. Okay, I plotted the data and I see the curve here. I can see the curve. So now, how do I find the line, a line that represent all these data point? Can anyone suggest to me what to do? We learned about this before, yeah? This is not something new to you.
Using the interpolation method?
Why interpolation?
To find the equation N1 and stuff.
Yes. Why interpolation? Why not? Why not regression?
Yeah. So the linear regression.
Regression or interpolation? This is the topic under curve fitting, under curve fitting. The one before differentiation and integration. So the question is, when do you use interpolation and when do you use integration? I think I gave you an assignment, assignment 6, I guess, regression. And I gave you the SR, the sum of residual square equation. Okay. I think it's the same thing in the project. Okay. Project 1 is the same. Project 1 pun sama je. Project 1 is also asking about sum of residual squares. So when do you use when do you use interpolation, and when do you use regression? That's the main question here. Some student, sorry to say, from my experience, dia student ni, dia nampak curve je, dia terus buat regression. Ada student pula, dia nampak aja curve, dia terus buat interpolation without thinking why. I'm not worried about your regression skill. I'm not worried about your interpolation skills. But when to use is more critical. Sebab to do regression, okay, you understand the basic, and nowadays Excel can do it for you, MATLAB can do it for you. But if you choose the wrong method, it will be wrong. So now, when to use regression and when to use interpolation, this is the most important thing. Okay, dan dalam test, student always didn't check first. Dia tak tahu. Sebab itu sorry to say, lagi sekali saya sorry to say lah masa saya mengajar budak-budak masters you know what my master student told me? Alah doktor, kami ni cat monkey je. You know what it meant by cat monkey? Bermaksud kalau dia punya employer tu, Mak Saleh, train a monkey to use cat software, monyet tu pun boleh buat. Itu sedihnya kita punya engineer. My student told me that. Dia rasa sedih jugalah sebab the employer Mak Saleh ni treat dia macam cat monkey lah basically. Sebab Mak Saleh punya pandangan terhadap orang kita, orang Malaysia ni, third world country ni, macam tu. Saya sendiri pernah kena. This is my own experience. Masa saya kerja dengan Bureau Veritas, a French company, they told when kita dapat pelawat, my CEO introduce me lah, introduce the pelawat to me, Mak Saleh lah. Mak Saleh tu tanya, the first thing Mak Saleh tu tanya saya, bila my CEO introduce me to the Mak Saleh, dia kata apa tau? Okay, this is our principal engineer, Dr. Fuad. The first thing Mak Saleh tu, sebelum salam saya, the first thing dia tanya saya apa? Where did you get your PhD? Saya kata kurang ajar punya Mak Saleh. Sebab apa kurang ajar? Dia nampak kita rendah tu. Saya cakap no, saya cakap dia, I get it from your country, the US, the USA. Sebab Mak Saleh tu Mak Saleh US. Terkejut dia, berubah muka dia bila dia cakap macam tu. Sebab dia pandang kita ni, dia ingat kita ni dapat PhD daripada Universiti Koman-Koman ke apa. Tu saya marah betul. So please this is the perception this is the perception. Sebab saya bekerja di Malaysia, saya orang Malaysia, dia ingat saya pun belajar dekat Malaysia. No. So please. So this is the level of thinking yang saya nak sebenarnya untuk pelajar saya. It's not the method, it's the understanding yang lebih penting. The understanding when to use regression, when to use interpolation. So in this case, what's the clue? What's the clue here? When you do regression, what did we do? What did we differentiate? Remember that we need to do this for our regression. Remember? Why are we doing this in our regression? So kalau kamu tak tahu ni, which mean kamu tak faham, and you are trying to memorize the method. You are not trying to memorize the understanding. Why are we doing this? Why do we need to differentiate with respect to A0 and A1 and set it equal to 0? Why? Anybody? Can anybody tell me? This is very important This is very important in understanding. Kalau kamu nak tahu method aja tak ada masalah. Nak jadi technician tak ada masalah. Okay, but if you are becoming an engineer, This is very important. Okay, again, itu yang membezakan tahap pemikiran technician dengan engineer. Engineer is always a level up than the technician. That is why to be a technician, your level of education is diploma dah cukup. To become an engineer, a bachelor's level is minimum. Tapi saya tengok dekat Malaysia ni sama je. So what's the difference here? Why are we doing this in our regression? Remember that we have SR equal to yi minus A naught minus A1 xi square. Okay, this one is for the linear regression. And then we set this to become, the differentiation become 0. Why is that? Why is that? What's the idea behind regression? Okay, so that's the most important thing that you need to understand. That is why cara saya mengajar, I derive all things because I need you to understand. Kalau saya nak kamu tahu method aja, saya akan beritahu the first thing you buat ni, the second thing you buat ni. Saya akan beritahu steps saja. Saya akan beritahu steps saja. I don't need to tell you what to do, to understand. Saya akan beritahu, okay, dapat data buat ni. Lepas tu buat ni, and then you get the result. Okay, that is method. That one is method. Yang itu level diploma boleh. Tapi engineering graduates, bachelor's level tak boleh lah. So what's the difference here? So now, a function that represents all data here, what are we going to use? This is again, macam saya kata tadi, this is under curve fitting topic. Curve fitting. And curve fitting ada dua. There are two methods here. Either you can use regression or you can use interpolation. So the question now is which one we are going to use here? Which one are we going to use? So basically kita nak buat curve fitting. Curve fitting. So what is curve fitting? Curve fitting is just this. Okay, so finding a curve. Okay, finding a curve. Itu yang kita nak buat. But how do we find the curve? Are we going to use regression or interpolation? Okay, so I think time is up. Masa dah tamat. So I need to stop here because I think you have other classes to go. Please think about this. Can we continue this on Thursday? Boleh?
Betul.
Semua orang tak boleh nak jawab soalan senang. Soalan senang ni pun tak boleh nak jawab. Saya sedih dengar. Okay, I'm kind of disappointed lah. Disappointed, sedih. Sebab saya rasa saya ni bercakap dengan skrin je selama ni. Okay, tak masuk pun satu yang saya ajar. All the derivation tu, saya rasa sedih lah. Saya rasa sedih lah sebab semalam saya jumpa klinik. Doktor tu, kakak dia ke adik dia bertugas di UTM. Dia tanya saya. Dia kata, saya rasa sekarang kualiti student kita makin teruk. Dia je cakap tu, bukan saya. Saya kata, entahlah doktor, saya pun dah tak berapa minat nak ni. Sebab saya pun dah nak pencen, saya kata. Tapi orang luar notice. Orang luar notice. So, saya daripada dulu cara saya mengajar macam tu. Saya cuba improve supaya kamu lebih understand. Tapi soalan simple macam ni tak boleh nak jawab lagi. Very sad lah, very sad. Tak apalah So, I give you time. Please think about this. Nak guna regression ke, nak guna interpolation. And let me know on Thursday. Boleh Alright, so thank you very much everyone. So kita jumpa lagi hari Khamis Thank you.